we're going to review compositions and inverses. So our first question is a composition. They give us two functions and they want us to find the composition of f of g. That's how this can also be written. And g of f. G of f. So let's do f of g first. F of g, this is f. And I'm going to plug g inside. So this is the composition of f of g. Now let's simplify this. I can distribute this 1/3 so that I get x plus 1/3 and then a minus 3. If you want to combine these numbers, they have to have the same denominator. So I can turn this into a fraction. I want these denominators to match. So the way I do that is multiply this denominator by a 3. Whatever you do to the denominator, you must also do to the numerator. So this becomes x and 1/3, so plus 1/3, and this is 3 times 3, which is 9. 1 times 3 is 3. So notice they have the same denominator. Now we can combine it. So we have x, and then 1 minus 9 is a negative 8 over 3. So that is your first composition. Now let's do g of f. So this is g. This is the g function. Instead of x, I put parentheses. Now I'm going to put f inside. So this will be 1/3 x minus 3. And again, we can simplify this. Distribute in the 3, so this becomes x minus 9 plus 1, which is just x minus 8. So that is your other composition. Now the domain for both of these are all real numbers, negative infinity to infinity. And that is how you write the domain in interval notation. I'm going to do f of g of x first. So f of x is parentheses cubed minus 4. That's what f of x is. And I'm going to put g inside. The cubed root cancels out with the cubed. So I'm left with x plus 7 minus 4, which is just x plus 3. Let's do the other way around, g of f of x. So this is g, this is g, and I'm going to put f inside. Now let's simplify it. This is just the cubed root of x cubed. Negative 4 plus 7 is 3. So this is your other equation. Okay, now this is just a linear line. Your domain is all real numbers, but in interval form, it's negative infinity to infinity. And the cubed root function looks like this. That's also all real numbers, negative infinity to infinity. Also, both of the original ones, the domain and range for f of x and g of x are all real numbers. So that means your composition will also be all real numbers. Next one. A store offers customers a 30% discount on the price X of selected items. So you go to the cash register and let's say this is your total amount. You get a 30% discount. That means you only have to pay 70%. So multiply this by 70%, but write it as a decimal. That is your first function. Now, you only have to pay 70%. After that, the store gives you an additional $15 discount. So however much you have to pay, you get to subtract 15 from it. That is your other function. So first you did f of x, only taking 70% of the price, and then you subtract an additional $15. So you do f of x first, and then you apply g of x. So g of x is x minus 15, and then you do 0.70x. So this is the composition. We put f inside of g. This is read as g of f. So that is your composition. Next one. And if you want an example of this, let's say you had to pay $150. Well, if you only have to pay 70% of that, If you get a 30% discount, that means you only have to pay 70%. So 150 times 0.70, that means you only have to pay $105. And then you get an additional $15 off. So that means you only have to pay 90 bucks. So that's how you apply this problem. Okay, let's try another example. It looks like this is your composition. So we want to know what the original functions were. Because h is f of g, okay? So we're plugging g inside of f. Well, that means g has to be 6x minus 5. And f of x has to be x cubed. Because what you did was, you put g inside of here. And that's what gave you this composition. So this is called a decomposition. We're going backwards. They gave you the composition and we're going back to find what were the original functions. Okay, here's another decomposition problem. This is the composition and they want g of f. G of f. Okay, so that means this had to be f because that's what you plugged in to g. We put this x plus 2 inside right here to get the composition. So we worked backwards. That's called a decomposition. Okay, so now we're going to verify that these two functions are inverses by doing a composition. So I'm going to plug g inside of f. So this is f, and I'm going to plug g inside, 5x plus 2. And you need to do this step by step. If you just do this, that is wrong. I need to know what order you did stuff in, okay? Because if you do this first, that's not correct. So 2 minus 2 is just 0. So you're left with 5x divided by 5. And then 5 divided by 5 is just x. So that's the first composition. Let's do it the other way around. I'm going to plug f into g. So this is g. This is the g function. I'm going to plug f inside. And guys, whenever you see everything divided by 5, you can split this up. You can write this as x over 5 minus 2 over 5. And maybe that might be easier for you to simplify it. So I'm going to distribute the 5. So this will become 5x over 5 minus 10 over 5 plus 2. Well, 5 divided by 5, that's just x, minus 10 divided by 5 is just 2, and then you have plus 2. Well, negative 2 plus 2, that's just 0, so you're left with x. So because I'm left with x both times I did the compositions, f and g are inverses. We're given f of x equals 3 minus 4x, and we want to find the inverse and give the domain. Okay, so f of x, this is just a line, mx plus b. It's swapped, but it's just a line that looks like this. Actually, this is a negative slope, so it looks like this. But anyway, the point is that the domain and range of a line is just negative infinity to infinity. And that means the inverse will have the exact same domain and range. Okay, so now let's find the inverse. We already know what the domain is going to be because it's just a line. But let's find the inverse. So you're going to do x equals 3 minus 4y. All I did was switch x and y. And now we're going to solve. Subtract 3. So you get x minus 3 equals negative 4y. Then divide everything by negative 4. You can imagine a 1 right here. So my answer is negative 1 over 4 x, and a negative 3 over a negative 4 is a positive 3 over 4. So this is your inverse. Let's try the next one. This is a square root function that went to the right 4 units. So if you were to graph it, 1, 2, 3, 4, it looks like this. So that means the domain is from 4 to infinity, and the range is from 0 to infinity. That means if you swap it, that's going to be the inverse's domain and range. So the domain for the inverse will be this, 0 to infinity, and if it asks for the range, it would be 4 to infinity. It just swaps. Now, if you want to find the inverse, you swap x and y. So we're going to do x equals the square root of y minus 4. So you're going to square both sides. The square root and the squared cancel out. You're left with x squared equals y minus 4. The last thing you do is add 4 to both sides. So your answer is x squared plus 4. Now, if you were to graph this, this is a U-shaped graph. It's a parabola that went up 4. So 1, 2, 3, 4, it's right here. And it's going to look like that, but normally it's a U-shaped graph, but we're not taking the left side. We want it to be the inverse. Inverses have to reflect across the line y equals x. That's why we're not taking this half. So normally, yes, this would be all real numbers for the domain, but it's restricted. I'm only taking from 0 to infinity, 0 to infinity, so that they can be reflections. Because guys, for the original problem, I only took these numbers. That means when you do the inverse, you're only going to have this part. Okay? So it's restricted. Okay, last problem. We're given the function, and I'll go ahead and graph it. It's at -7 for the y-intercept. So this is my graph. -7, 1, 2, 3, 4, 5, 6, 7, right here. And your slope is 5. So you're going to go up 5 over 1. Up 5 over 1. So this is your original function, f. And let's find the inverse. Well, you could just simply switch x and y. So this point right here is 0, -7. This point here is 1, -2. This point is 2, 3, and this point is 3, 8. Uh-oh. This point is 3, 8. So if you want to do the inverse, you just switch x and y. So let me list the points that I'm going to have on the inverse so you can see. I'm going to have -7, 0. I'm going to have -2, 1. I'll have 3, 2. And I'll have 8, 3. All you have to do is switch x and y to find the inverse, just like you do when you're solving the equation. So I'll graph these. -7, 0 is right here. -2, 1 is right here. 3, 2 is right here. And 8, 3 is right here. So this is your inverse line. And notice, it reflects across the line, y equals x. So the question asked you to graph its inverse, and you did. Now, if you wanted to do it algebraically, you can. So let me show you that part as well. If you want to do it algebraically, you switch x and y so that you'll have x equals 5y minus 7. And then you would add 7 to both sides so that you get x plus 7 equals 5y. Then you would divide everything by 5. So that means the inverse equation is 1/5 x plus 7/5. And I think that's a bit difficult to graph because these are all fractions, but you can kind of notice that this right here is about 7/5. And it goes up 1/5 every time. All right, so that was the review.